Assalamualaikum warahmatullahi wabarakatuh, everyone. So today we are going to talk about Faraday's law. This concept we are going to learn from the physics subject in our learning session. So the first one, let me introduce myself first. My name is Ainul Fatihah binti Muhammad Kusri, and then my friends is, the first one is Muhammad Suhail Daniel bin Muhammad Shah, the second one is Muhammad Haziq Irshad bin Muhammad Samsu, and the third one is Muhammad Arif bin Saiful Azmi. And we are from group K7, and we are also a student from University Putra Malaysia of Foundation classes. So let's move on to the next slide. The first one, before we are going to learn about this Faraday's law concept, we need to know about the objective. The first one is to determine the concept of Faraday's law, how it will be begins, how this concept can be running on. So the second one is to observe how galvanometer respond to the movement of magnet. Next, let's move on to the next slide. What is Faraday's law? So let me tell something about this Faraday's law theory. Actually, Faraday's law states that the induced voltage in a circuit is proportional to the rate of change over time of the magnetic flux through that circuit. In other words, the faster the magnetic field changes, the greater will be the voltage in the circuit. The direction of the change in the magnetic field determines the direction of the current. So next, my friend will show an experiment about this Faraday's law concept and tell a bit about the expectation result from this experiment. So stay tuned.
Assalamualaikum and hi, I'm Muhammad Sulaiman bin Muhammad Shah, and today I'm going to show you guys the expected result for the Faraday's law experiment for the 2 loops and 4 loops, which is, first of all, when the magnet is moving towards the coil, so the voltmeter will show the negative direction, and also the bulb brightness will be dim for the 2 loops coil, and for the 4 loops coil it will be brighter than the 2 loops. And while the magnet is not moving while inside or the outside of the coil, the voltmeter pointer will show no direction of current, and the bulb brightness will be not produced because there is no current produced during the experiment. And also, while the magnet is moving away from the coil, the voltmeter pointer will show a positive direction, and the bulb brightness will be brighter for the 4 loops coil. And for the methodology in this experiment, so first we need to click to the simulation page, and we need to choose the setup with 2 coils that I will show next, and we will start to move the magnet towards the coil and observe if there are any changes to the galvanometer and the bulb, and then we will make the magnet stay inside of the coil and then see if there are any changes, and then move the magnet away to see any changes, and then we will hold the magnet stationary outside of the coil to see if there are any changes to the galvanometer and the bulb, and then we will repeat the step during using the 3 and 4 step to see if there are any changes to the brightness or to the direction using the 4 coil loop. So then I will show you the methodology using the video. So here is the video. So that's all for the experiment, and thank you for listening to my explanation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Arif. I will present for the result, discussion 1 and discussion 2. Okay, for the result, we have come up with the 4 items, which is the coil, magnet movement, government with the pointer direction, and the brightness of bulb. For the coil, we have come up with 2 different number of loops in the coil, and the first one is coil with 2 loops, and the second one is coil with 4 loops. And for the magnet movement, there are 4 types of movement, which is towards the coil, inside coil, away from coil, and outside the coil. And galvanometer pointer direction with positive value, 0 value, and negative value. And brightness of bulb, we've come up with when either is no light, dim, nor bright. Alright, for the first coil 2 loops, magnet movement towards the coil will come with the negative value in the galvanometer, and the brightness of bulb is dim. And the second one is magnet movement inside coil. The value is 0, which will come with the no light to the bulb. And the next one is away from coil. We'll come up with the positive value to the galvanometer, and the brightness of bulb is dim. And the last one is outside coil, with galvanometer pointer direction is in 0 value, and the brightness of bulb is no light. Okay, when they towards the coil, there are repulsive force that happen between the magnet and the coil. So the galvanometer will pointer to the negative direction, and the magnet movement when away from coil, there will be attractive force between the magnet and the coil, which bring up to the positive value in the galvanometer. We can see there are the same result between the coil in 2 loops, coil 2 loops and coil 4 loops, but somehow the brightness of bulb is different. This different is because of the number of loops that in the coil. When there are more loops, they will bring more electromagnetic force and will come out with the more current to the bulb. So we will bring the more brightness to the bulb. Okay, this is the result that we get from this experiment. Okay, let's go for the discussion 1. For the discussion 1, the question is about define Faraday's law. Right, but from this answer we can see that Faraday's law of induction describes how an electric current produces a magnetic field, and conversely how a changing magnetic field generates an electric current in a conductor. Other than that, Faraday's law is a basic law of electromagnetism, predicting how a magnetic field will interact with an electric circuit to produce an electromotive force or EMF, a phenomenon known as electromagnetic induction. This fundamental operating principle of transformers, inductors, and many types of electrical motors, generators, and solenoids. You can see that actually Faraday's law is described how electric current can produce a magnetic field, which also will come from the magnetic field, also will produce the electric current. And we can see this phenomenon is actually happen in some of a few items that we usually know, like transformers, inductors, or like motors in our motorcycle, and generators that provide us electric every day. Okay, this is for the discussion 1. And for the discussion 2 is which coil produces the brighter light? Explain. Okay, for the answer is the coil that produces the brighter light is a coil with 4 loops. I've explained it during the result, at the result. Okay, that more number of loops will bring brighter light, and this is because when increasing the loops of wire in the coil, the electromagnet will become stronger. Okay, because there are more magnetic field lines in the loops. Hence, the light bulb becomes even brighter, and the rays in its emitting become longer compared to the wire with 2 loops. So, the coil with the 4 loops has the brighter light due to the higher number of loops in the coil. Okay, I think that is the answer for discussion 1, and that's all from me. Thank you.
Okay, next I want to share or explain about the factor that affect of the magnitude of induced EMF. Okay, firstly, the factor that affect the magnitude of induced EMF is the number of turns in a coil. So, when the number of turns in a coil increase, the EMF also increase. While when the number of turns of coil is decreased, the EMF also will decrease. So, next is the speed or rate of the conductor move or cutting the magnetic field or coil. Okay, so when the speed or the rate of cutting the magnetic field is high, the EMF produced also will increase. Okay, so next is the length of the conductor. So when the length of the conductor is increased the length increase, the EMF also will increase. Okay, so that is the factor that affect the magnitude of induced EMF. So the conclusion is if the induced voltage is occurred is proportional to the rate of change over time of the magnetic flux through that circuit. It means that when the rate of change in magnetic flux increase, the voltage or EMF produced in the circuit also will increase. So other than that, when the loop of wire in the coil increase, the electromagnet will also increase, which means will make the bulb become more brighter. Besides, when the number of turn wire of coil decrease, the electromagnet produced also will decrease, thus make the bulb become dimmer. Okay, so that's all for our presentation. So a bit sharing regarding this virtual lab. We think it is more easier than we do practical lab. So basically, when the practical lab, we have methodology. Okay, we also done what methodology state. Also same to the virtual, but it's become more easier because we do it on internet. So we will not physically do it, we virtually. So we just need to do what already stated in the methodology, and it also easier because we can avoid such error like parallax error and abnormal data that we got from the experiment. So the experiment will reach the expected result and thus make the data more reliable and the experiment can be done more successfully. Okay, so that's all. Thank you.